Hello students, Miss Slyman here at home feeling pretty congested, but I've got my iPad so I can make your video. So this next unit is on volume, or this next part of the unit is volume, and you're going to be doing a lot of stuff in this Google form here. It's actually made with Form Plus. And the first thing that I want you to do is I want you to think about the volume formula. So the most basic volume formula is that volume is equal to area times height. And I want you to think about area and height and think about why do you think that the multiplication for area times height is volume? And I want you to post it to the form. So that's thing one. So maybe you want to pause this, go to the form, keep the form open in a separate tab because you'll need it again at the end of the video. However you want to do it. Okay, so given that volume is area times height, we can find areas of different shapes, and I was actually going to make this video with my computer so that I could show you how to draw 3D shapes using the computer, but I don't have that with me. As you can tell, I'm a little bit fuzzy-headed. So I'm just going to draw it by hand. So a prism is sort of any general 3D shape that is made from a quadrilateral. So for example, if we started with sort of like a trapezium, or, well, that looks like a parallelogram, and then extended it off. And that sort of looks 3D-like, kind of. There we go. That's a little bit better. Okay, so then a cross-section of that is anywhere I could take a slice and it would look the same. So here, a cross-section would be like a front parallelogram. And then my height would be the distance of all those different parallelograms. So in this case, the cross-section is going to be a quadrilateral. And so the volume formula is going to be the area of that quadrilateral times the height. And I'm using that subscript Q to say that it's the area of the quadrilateral. And we'll get more specific with our cuboid. Our cuboid, I'm going to draw down here. So a cuboid has one side that is a rectangle. And so there's a cuboid. So a cross-section is a rectangle. So it's a type of prism, that's why I have it indented over here. And its volume formula is area, but we know that the area of a rectangle is length times width, and then we call the distance to the back the height. So length times width times height, because area is length times width. Okay, a cube, well, I think you all know what a cube is. A cube is made of squares. So a cube has all sides the same, and its cross-section is a square. So if I look at just one face, I get the square. So then the volume is length cubed, because it's length times length times length, because all the lengths are the same. A cylinder, I'll go ahead and draw that here. Cylinder is like a water bottle. That's my example later. So it's got circle on the bottom, circle on the top. So it's here, in this case, the cross-section is the circle, because if I slice it any way horizontally, so if I slice this way, then I'm always going to see a circle. Whereas if I sliced going up, down, all those pieces would look different. But if I sliced this way, like slicing a salami, then all the slices look the same. So in this case, the cross-section is a circle. And so then the volume, well, the area of a circle, pi r squared, and then times the height. So in this case, our height would be here. That's our h. And of course, we would have a radius in the middle of the circle. So if I look at an example, here's a container. It's made with a trapezium. And so anyway, if I sliced it sort of from the top and then sliced down, like if I put a knife through it, then all the shapes would look like this. So that's my cross section. So my volume is going to be the area of the trapezoid times the distance between all the trapezoids, which we call the height. It's not necessarily up-down height though. In this case, our height is 15 because that's our distance of trapezoids. So I'm going to switch back to the black here. Our volume, well, area of a trapezoid, base 1 plus base 2 times height of the trapezoid, divide by 2, times the height of the 3D shape is 15. And I don't have my calculator with me, so you guys will have to put that in, work it out, and figure out what it is. I can shorten it a little bit. 10 plus 22 is 32. This 8 divided by 2 is 4. So 32 times 4 times 15. It's going to be a big volume. And our volume is centimeters cubed. And that really comes from multiplying centimeters by centimeters by centimeters. So that's why we have centimeters cubed. Okay, like I said, a volume can be a cylinder, and a water bottle can be a cylinder. So this is the water bottle I have at home, and I did some measurements. So here's the 8 centimeters. That's the 8 centimeter line down here. So actually, the diameter of the water bottle was 7 centimeters. So here was my diameter. It ended here. So our diameter was 7 centimeters. That means the radius is 3.5 centimeters. The height, when I had this flat down on the table, was 18.5 centimeters. So volume for a cylinder, our volume is going to be pi r squared times the height. And again, I still don't have my calculator, so you guys can put that in your calculator. But remember, if we want to leave it exact, we want to leave the pi. So the only thing I'm putting in the calculator, 3.5 squared times 18.5. And so now I would like you to find a container in your house and take some photos of it and upload your photo and create an example. And it can be, what is the area or what is the volume of my, lunchbox? Whatever you would like to do, and put it onto the same form. There should be a place where you can upload a photo. I think I actually made it so that you could only upload one photo, but you could submit several times. So that should work just fine. And I hope to see you back in class on Wednesday. Hopefully I'll be feeling better. Okay, bye-bye.